Hi, I'm Dhara. I'm an astronomer here at the Royal Observatory, Greenwich, and in this week's space news, astronomers have detected 12 black holes around the supermassive black hole at the centre of our galaxy. And although this seems like a small number of black holes detected, it actually provides great support to the theory that there are actually many black holes around that supermassive black hole that lies at the centre of the Milky Way. So what is a black hole? Well, it's a very dense and compact object. It's lots of material crammed into a very, very small space. In fact, if we were to turn the Earth into a black hole, we'd have to take all the material on the Earth and cram it down into something that was the size of your thumbnail. So we're talking about a very, very dense and compact object which has a huge gravitational pull. And around the black hole is the event horizon, the point of no return. And it's only when you go past the event horizon close enough to the black hole where even if you were travelling at the speed of light, you wouldn't be able to escape the black hole's gravitational pull. And that's why lots of people say that not even light can escape from it. But there are two types of black holes. So you get the supermassive black holes. They're the ones that are found at the centre of large galaxies. The one at the centre of the Milky Way is called Sagittarius A, and it is 4 million times the mass of our Sun, so very, very massive. The other types are called stellar mass black holes. These are formed when very large stars end their lives, stars that are much more massive than our Sun. They leave behind a remnant after the star has gone supernova, a tinier or smaller black hole. Those ones are roughly tens of times the mass of our Sun, so much smaller or much less massive. And the theory states that there should be thousands of these smaller black holes around the supermassive black hole at the centre of our galaxy. And that's because Sagittarius A has this huge halo of gas and dust all around it. And it's from that material that stars are born. So once those stars are born, they'll live their lives and they'll also end them too. When those massive stars end their lives, they should leave behind these black holes, and so we should find them dotted around by this supermassive black hole. Now the problem is we can't actually see these black holes. They're dark in nature, they don't emit any light or reflect it, so the only way we can actually detect that they're there is through the interactions they have with the material around them. Now it's a slightly windy day today, so although the wind is here and it's blowing my hair, I can't see the wind itself, it's invisible to me, but by looking at the effect it has on my hair, I know that the wind is here. And it's the same thing these astronomers are trying to do to detect those black holes. So what they're looking at is the interaction of these black holes with the stars that they have actually pulled close enough to become companions. So we call them black hole binaries. Now these black holes, when they interact with the material from these stars, can produce X-rays. Sometimes you'll get X-ray bursts, and these are caused when the black hole itself feeds on material from this star, so it's very active. But looking at these black holes that are so far away at the centre of our galaxy, it means that these X-ray bursts are only ever bright enough or strong enough to be seen maybe once every 100 or 1,000 years. So not in the kind of timescales we're working to. Instead, these astronomers are looking for the fainter but steadier X-ray signals that are given when these companion stars shed their outer layers, and that forms an accretion disk around the black hole. That accretion disk is full of very fast-moving and hot gas, and that emits X-rays, which we can detect. So the Chandra X-ray telescope was used to detect some of these X-ray signals. They were using archived data, and they found these 12 black holes in these binary systems with their companion stars. But in fact, looking at where those black hole binaries were and their properties, they actually assumed that there could be about 500 of these black hole binaries around Sagittarius A at the centre of our galaxy. They're actually isolated black holes too, and they're actually thought to be even more common than these black hole binaries. The problem again is that without an interaction from these isolated black holes, we can't actually detect they're there. But from all the estimates, they predict there are around 10,000 black holes around that supermassive black hole at the centre of our galaxy. And almost very timely, about this time last year, the Event Horizon Telescope started collecting data that would allow us to make the first image of a black hole. Now they say that if they've collected the data they've collected, if they combine it correctly, then we actually may have the first image of a black hole later this year. So something to keep our eyes on.